This video, we're going to talk about their divisibility rules. We'll start with number 2. How do you tell if a number is divisible by 2? And I'm sure you know this rule. A integer is divisible by 2 if and only if it ends in 0, 2, 4, 6, or 8. So 7, 2, 3, 1, 4, 3, 8, 3, 2, 6. This number is divisible by 2 because the last number is one of those numbers. 3, 8, 1, 4, 3 is not divisible by 2 because it doesn't end in one of the allowable digits. So you just look at the last number, the last digit. If it's 0, 2, 4, 6, or 8, the number is divisible by 2. You can divide it by 2 without having a remainder. Okay. For number 3, an integer is divisible by 2, I should have said. An integer is divisible by 3 if and only if the sum of the digits is also divisible by 3. So if you have 2, 3, 1, 4, 2, if you add these digits, 2 plus 3 plus 1 plus 4 plus 2, 5, 6, 10, 12. Since 12 is divisible by 3, so is this number. If you didn't know that 12 was divisible by 3, maybe it's a much larger number. Then you can add the 1 and the 2, and then you get 3. And at some point, you have to know what's on the 3 table. The second time I wrote 3. And it turns out that 1 plus 2 is 3, and this number is on the 3 times table. 3 goes into that number. So, all those numbers are divisible by 3. If you have 9, 9, 8, 9, 7, 3, 9, 4, 8. But when we add these numbers, I expect to get a somewhat larger number than 12. 9, 18, 27, 35, 45, 54, 62, I get 66. Now clearly that number is divisible by 3 because 3 goes into both of these numbers 2 times. But if you didn't know that, that's okay. If you didn't know that, so we're looking at these numbers, and then you get 6 plus 6 is 12. So either 3 goes into these 3 numbers or they go into none of them. The instant you know the answer, oh yeah, I know 3 goes in here. You're done, 3 goes in here. But if you didn't know if 3 went into 66, well then you can get down to 12. Does 3 go into 12? If you say yes, then 3 goes into all those numbers. If you still don't know if 3 goes into 12, you can do 1 plus 2 and get 3. 3 goes into 12, so 3 goes into 3 goes into 3. So 3 goes into all of these numbers. In particular, it goes into the last number. the number that we were interested in knowing about. Now, how about you have 1, 2, 3, 4? Well, if you add up those digits, you probably get 10. You get 10. Now, this is not divisible by 3. So this number is not divisible by 3. After all, 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And then 3 times 4, it goes right past 10. But if you didn't know that, you can add 1 and 0, and you get 1. This number is not divisible by 3. It's not on the 3 times table. So none of these numbers, especially the test number, 1, 2, 3, 4, is not divisible by 3. Why? Because when I added up the digits, my result was not a multiple of 3. Okay. So now, in a second or so, we'll go on to the divisibility rule for 4. And integer is divisible by 4 if and only if the last 2 digits is divisible by 4. If and only if the last 2 digits is divisible by 4. In other words, if you have 1, 2, 4, 8, 3, 6, look at 36. 36 is divisible by 4. 4 goes into 36 9 times. So this number is divisible by 4. 1, 3, 8, 4, 1, 4. 4 does not go into evenly. 4 does not go into 14. It has a remainder. So no, 4 does not go into this number. So if you just want to know if this number is divisible by 4, it suffices just to look at the last 2 digits. If 4 goes into that number, then 4 goes into the bigger number. If 4 does not go into the last 2 digits, then 4 does not go into 138,414. Just check the last 2 digits. 5. And integer is divisible by 5 if and only if the last digit is 5 or 0. Very, very simple rule. 7, 2, 3, 4, 5. Is this number divisible by 5? Just look at the last digit. If it's 0 or 5, then it's divisible by 5. 3, 8, 1, 4, 2, 3. This last digit is not a 0 or a 5. It is not divisible by 5. 8, 5, 2, 1, 0. That last digit is a 0 or a 5. It's a 0, so it's divisible by 5. Just look at the last digit. If it's not a 0 or 5, 5 won't go into it. If it is a 0 or a 5, like these two numbers, This one's a 0, the last digit. That's a 5. 5 goes into that number. Just check the last digit. It's even easier than divisibility by 2. In 2, you have to know 5 numbers. If it ends in a 0, a 2, a 4, a 6, or an 8. 1, 2, 3, 4, 5. Here, you just have to remember 2 digits. If it ends in one of those 2 digits, it's divisible by 5. 6. And integer is divisible by 6 if and only if the integer is divisible by 3 and 2. That means it has to pass the divisibility rule for 3 and 2. So, if I give you this number, you immediately say no because it failed the 2 test. This number is not divisible by 2. If I give you this number, when it comes to the 2, it passes. This one failed the divisibility rule by 2. So it passed the divisibility test for 2. That was pretty quick. Now does it pass for 3? Well, that rule says you add up the digits. 7 and 3 is 10, 14, 15, 19. This number is not divisible by 3. If you really don't see that, you add the 1 and the 9. You get 10. If you don't see that, then you add the 1 and the 0. At some point, you have to say no, either to this one or to this one or to that one. But once you say no, they're all no. This number here failed the 3 tests. So no, it is not divisible by 3. Definitely check for divisibility by 2 first. It can be done by inspection. Just look at the last digit. Okay, it's a lot harder to add up. Well, it's a lot harder to add up those digits to see if it's a multiple of 3 or not than it is to see if it's see if it ends in a 2, 4, 6, 8, or 0. So the divisibility rule for 6 is just verify the divisibility rule for 2 and for 3. So if you want to make up a number that will be divisible by 6, make sure the last digit is even, and then make sure the digits add up to a multiple of 3. 4 plus 3 is 7, plus 6 is 13, plus 2 is 15. This number is divisible by 2. We rigged it to be divisible by 6. We rigged it to be divisible by 2 by putting an even digit at the end, and I also rigged it to be divisible by 3 because I made sure the sum of the digits, which is 15, is a multiple of 3. I can do that all day long. I'll pick an even digit for the last number. Say you want a 6-digit number, 1, 2, 3, 4, 5. I can pick any numbers I want for these 4 digits, and then I add them up. 0 plus 3 is 3, plus 4 is 7, plus 5 is 12, plus 2 more is 14. Now remember, multiples of 3 are 3, 0, 3, 6, 9, 12, 15, 18, 21, 24. Well, we can't have them add up to these numbers because they already add up to 14. And if you're 14, the most you can add for one more digit is 9. So we can't be 24. We can get it to be any one of those 3 digits. How about we pick 21? Well, if they already add up to 14, excuse me, you add 7. There it is. This number is divisible by 6. 6 into 7, 2, 5, 4, 30. 6 goes in there 7 one time with 1 left over. Bring down the 2. 6 goes into 12 with nothing left over. Bring down the 5. 0, 5 is 5. 6 goes into 5 0 times. We subtract, we get 5. Bring down the 4, which is not a 9. And then ask yourself how many times does 6 go into 54? Goes in 9 times. That's 0. Bring down the 3. This number here is just 3. 6 does go into 3 exactly 0 times. Subtract, you get 3. Bring down the 0. And 6 goes into 30 exactly 5 times. Okay, this method does work. Verify that it's an even number. Sorry, it's divisible by 2, which means it's an even number. And also make sure it's divisible by 3 by making sure that the sum of the digits is on the 3 times table. Number 7. Number 7 is a bit awkward, but it can be done. An integer is divisible by 7 if and only if a minus 2b is divisible by 7. Now, the real question here is, what's a and b? What is an a and what is a b? Because I can't tell if this is divisible by 7 if I don't know what it is. Well, every number, 723 or 1723, it's 10 times that number is 10 times 172 plus that number. And to verify it, 10 times that number is 1720. And when you add 3, you do get 1723. This is the A and this is the B. The A is everything but the last digit, and B is the last digit. No matter what number you have, 3233742. This is equal to that number, 32374 times 10 plus 2. That's my A, that's my B. That's A, and that's B. Okay, so let's pick one that does work. Suppose you have 1, 2, 3 times 7. So if I do my multiplication right, this number should be divisible by 7. 861. So 861. That's A and that's B. So we take A and then we take away 2 times B. That's 84. Now, if you know if 7 goes into 84, you're okay. If you don't know if 7 goes into 84, you take that number and you take away 2 of those. 2 4s are 8, and you get 0. And this number is divisible by 7. If I take 0 and I divide it by 7, I get a nice integer, no remainder. So that means this number is divisible by 7, and this number was divisible by 7. If I give you 12, 8, 4, 3, well, this is A, 1, 2, 8, 4, and I take away 2 times 3, and I get 1, 2, 7, 8. If you know if 7 goes into that number, wonderful. If you don't, just take the A part and take away 2 times 8, which is 16. Now you get 1, 1, 1. If you don't know if 7 goes into that number, you take those 2 digits and you take away 2 ones. And then you get 9. No, 7 doesn't go into 9. 7 doesn't go in here. 7 doesn't go in here. And 7 does not go in there. If you want to verify that, do the long division. 7 goes into 12 one time, 5 left over. Bring down the 8. 7 times 8 is 56. You have 2 left over. Bring down the 4. 7 times 3 is 21. 3 left over. And 7 doesn't go into 33. 7 times 4 is 28. You get a remainder of 5. That is, this number was not divisible by 3. I'll do one more. Let's make sure it works. What if you have 10832 times 7? I'm making sure it works by picking a multiple of 7. 22, 58, that number. This number, if I multiply it correctly, is divisible by 7. So I take everything but the last digit, and then I take away from that number, this number here, I take away 2 of those. 7, 5, 7, 4. I don't know if 7 goes in there. What am I, a computer? So I take 7, 5, 7, and I take away 2 of those. And I get 7, 4, 9. You really should know that 7 goes into 7 evenly, and 7 goes into 49 evenly. But if you didn't, you take 74, and you take away 2 9s. This gives you 56. And you really should know that that's 7 times 8. But if you insist you didn't, you take 5, and then you take away 2 6s. And that gives you -7. That number is divisible by 7. It goes in -1 time, no remainder. So either all of these numbers are divisible by 7, or none of them are. Since one of them, whether it be this number or even this number, okay, those aren't too hard to see. If one of those is divisible by 7, then they all are. In particular, that number. That is one method of finding out if a number is divisible by 7. Other methods are very similar. It just won't be a minus 2b. It might be a plus 7b. A plus 5b. Right. Now, next number is 8. And this one, it's not bad. An integer is divisible by 8 if and only if the last 3 digits is divisible by 8. Just look at the last 3 digits. Do long division with that. In other words, I don't know, 8 times 32 is 16, 24, 25. So 8 goes into the last 3 digits. You can pick any other numbers you want. It doesn't matter what you pick. 8 goes into this number. 8 will go into this number. 8 goes into 8 one time. Subtract, get 0, bring down the 4. 8 goes into 4 0 times. Bring down the 3. 8 goes into 43 5 times. That used up 40. You get 3, bring down the 2. 8 goes into 32. You know what? I want to make this a 3. I don't want 8 to go into everything but the 256. So instead of bringing down a 2, I bring down a 3. 8 goes into 33 4 times. And we have something left over. Bring down the 2. 8 goes into 12 one time. Subtract the 1, 8, get 4. Bring down the 5. 8 goes into 45 5 times. So I take away 40, and look at this. 8 goes right into 56 7 times. If it goes into the last 3 digits, 8, then it will go into the number, the whole number. It will go into this whole number because 8 went into the last 3 digits. If I added 2 to this number, 258, well then 8 doesn't go in there. So if I take any number, 1, 2, 4, 3, 2, 5, 8, that's not an 8. 4 will not go into this number because 4 does not go into the last 2 digits. I'd have to add 8 or 16 or 24 for 8 to go into this sum. Okay, 8 goes in, 4 go, 8, what am I doing? 8 goes in there one time. 4, bring down the 4. 8 into 40 goes 5 times with 4 left over. Bring down the 3, goes in 5 more times. Subtract, you get 3. Bring down the 2. 8 goes into 32 exactly 4 times. 0 remainder. Bring down the 5. 8 does go into 5 0 times. Subtract, get 5. Bring down the 8. And here's the problem. 8 goes into 58 7 times with the remainder of 2. Of course the remainder is going to be 2 because I took a multiple of 8 and I added 2 to it. So it doesn't go in evenly. 8 does not go into this number because 8 did not go into 258. 8 goes into 256. It's going to be, okay, it goes in 3 times. It's going to go in 32 times. That's 24 with 1 left over. 258. 258. Bring down the 8. 8 goes in there 18 2 times. And look at that. There's 2 left over. Since 8 does not go into the last 3 digits, it has a remainder, then 8 will not go into the bigger number. So the rule for 8 is you have to do long division. Like for example, if I just ask you on the right here, does 8 go into that number? You'd have to do the long division. You'd have to say, I don't know, let me try. If I give you a bigger number, you still have to do the long division for the last 3 digits. I gave you this big number, you just have to do the long division for the last 3 digits. It's a lot better than doing it for 7 digits, like the examples I've given. I'd rather divide 8 into a 3-digit number than a 7-digit number or even larger. So that's the rule for 8. That one is probably the least friendly rule. It involves doing long division. The other ones just involve either inspection or adding and subtracting. Although 4, you have to see if the last 2 digits is divisible by 4. But dividing 4 into a 2-digit number, it's not that bad. Okay, let's go into number 9. Number 9 is very similar to number 3, except instead of saying 3, we say 9. And integer is divisible by 9 if and only if the sum of the digits of their number, of the integer, is divisible by 9. Okay, so 2 plus 3 is 5, plus 4 is 9, plus 2 is 11, plus 7 is 18. This number is divisible by 9. It's 2 times 9. If you didn't believe that, you can add 1 and 8 and get 9, and this number is divisible by 9. So all of these 3 numbers, especially the beginning one, is divisible by 9. 9 goes into 23 2 times with 5 left over. Bring down the 4. 9 times 6 is 54. You have no remainder. Bring down the 2. Think of this number as 2. 9 goes into 2 0 times. You subtract, you get 2. Bring down the 7. 9 goes right into 27 3 times with no remainder. Yep, 9 went into this number. If you take another number whose sum of digits is not a multiple of 9, like 1 plus 2 is 3, plus another 3 is 6, plus 2 more is 8, plus 2 more is 10. This number is not divisible by 9. So, this number is not divisible by 9. Let's verify that. 1 times 9 is 9. Get 3 left over. Bring down this 3. 9 times 3 is 27. 6 left over. Bring down the 2. 9 times 6 is 54. You subtract, you get 8. Bring down the 2. 9 doesn't go into 82. 9 times 9 is 81. You have a remainder. 9 did not go into this number. add up the digits. If it sums up to a multiple of 9, then 9 goes into the number. If it does not sum up to a multiple of 9, 9 does not go into that number. 10, the easiest one of all. And integer is divisible by 10 if and only if the last digit is 0. Here there's only one choice for the last digit, making this one so far the easiest test. Is this number divisible by 10? No, because that's not a 0. 32140303403. Lots and lots of zeros. The last digit is not a 0. This long number, it can have next to no zeros except the last digit. It can have many zeros. It can have many zeros. The last digit is 0. It's divisible by 10. Just look at the last digit. If it's divisible by, if it's a 0, it's divisible by 10. 11, very similar to the rule for 3 and 9. With a little twist to it. An integer is divisible by 11 if and only if the sum, if and only if the sum of the alternate signs of the number is divisible by 11. What on earth does that mean? Not sure I said it so well. Is this number divisible by 11? 7, 2, 3, 1, 4. Like always, well, not like always, we'll assume, so it's plus 7 minus 2 plus 3 minus 1 plus 4. We alternate the signs. This is 5, plus 3 more is 8, minus 1 is 7, plus 4 more is 11. That number is divisible by 11. You can also do 1 minus 1, alternate, plus minus, you get 0. And this number is divisible by 11. Since those are divisible by 11, so is this number. If you have 3, 2, 1, 1, 7, 2, 1, 9. 3 minus 2 plus 1 minus 1 plus 7 minus 2 plus 1 minus 9. Plus minus, plus minus, plus minus, plus minus, plus minus, and I wrote down all the digits. Okay. To make life easier, plus 1 minus 1, well, that's 0. 3 minus 2 is 1, plus 7 is 8, minus 1 is 6, plus 1 is 7, minus 9. That's negative 2. This is not divisible by 11. The only numbers that are divisible by 11 are numbers on the 11 table. And they can even have a negative sign in front of them. In other words, these are some numbers, the first few numbers, that are divisible by 11, and so are an 11 table. Let me put 0. And if I change their signs, they're also divisible by 11. You change the sign of 0, you still get 0. Okay? It doesn't matter the sign. So here I just look at 2. This number is not divisible by 11. Alternate adding and subtracting. Alternate adding and subtracting, and if the result is a multiple of 11, then you're okay. For example, 9 minus 1 is 8, plus 9 is 17, minus 4 is 13, plus 9 is 22. 9 minus 1 plus 9 minus 4 plus 9. 9, 8, 17, 13, 22. Since that number is on their 11 table, so is this. That is, they're both divisible by 11. If you didn't know if 11 went into 22, I mean, it could have been a 7-digit number. You just do 2 minus 2, you get 0. And that's on the 11 table. I can divide it by 11 evenly. So I can divide this number by 11. Let's try that. 91949 goes in 8 times, 3 left over. Bring down the 9. It goes 3 times with 6 left over. Bring down the 4. It goes 5 times with 9 left over. Look at this. Bring down the 9. 11 goes into 99 9 times. Yep, this number is divisible by 11. You can do the division, but if your question is it divisible by 11? All you do, minus 1, all you do is this. And you get 22, and you go yes. So you go yes to this number. This number right here is divisible. This number is divisible by 11 because when I alternated the signs, the result is a multiple of 22. Noah, even if you mess up, I don't think you would do this, but if you started with -9 and then you added 1 and took away 9 and added 4 and took away 9, you know what? You'll get -22. Just be careful and don't go 91949 and go plus minus plus minus. No, because that's an understood plus. These signs were not different. Those signs were different. Different again, good. Different again, different. Yeah, fair enough. These two are different, and those two are different, and those two signs are different. But again, these two signs are not different. Maybe it's best to always remember, start with a negative. That way you know to change the sign. Okay? Just remember the first digit, unless you make it negative, the first digit is positive, so then you best subtract next. That is the rule for divisibility by 11. Let us do one more. Then we'll talk about how powerful these rules are in reducing fractions. 12. And integer is divisible by 12 if and only if it is divisible by 4 and 3. That is, it has to pass the divisibility test for 4 and the divisibility test for 3. That's all. Okay, how do you pass the divisibility test for 4? The last two digits should be a multiple of 4. For example, 48's a multiple of 4. And you know what? Let's just look at 48. So it passes the test for 4. Does it pass the test for 3? Well, when I add up those digits, I get 12. And yep, 12 is divisible by 3. It turns out that 12 will go into this number exactly 4 times. No remainder. But let's look at a bigger number. So we know that no matter what digits I put here, since 4 goes into 48, 4 is going to go into this number. To get it to be divisible by 3, I do 8 plus 4 is 12, plus 2 more is 14, plus 1 is 15, plus 5 is 20, plus 3 is 23. So I'm up to 23. I can only add 1 or 9. Well, 23, the next multiple of 3 is 24, 27, 30, 33. Okay? The most I can add is 9, because, you know, that's the largest digit that can go there, a 9. And 23 plus 9 is 32. So I can't get to 33. And I can add 1, and 23 plus 1 is 24. So I could get to any one of these numbers. For example, if I put a 7 here and I added correctly, all of those digits added up to 23. I add 7 more, I get a 30. And 3 goes into 30. Okay? 12 will go into this number. 12 will go into this number. Why? Because 4 and 3 went into it. Let us test this, and then we'll talk some more. 12 times 6 is 72, with 1 left over. Bring down to 5. 12 goes into 15 one time, with 3 left over. Bring down to 1. 12 goes into our 31 2 times. That leaves 7 left over. Bring down to 2. 12 goes into 72 exactly 6 times. Bring down to 4. 12 goes into 4 0 times. 4 left over. Bring down to 8. And 12 does go into 48 evenly. It goes in 4 times. So yes, 12 did go into this number. And how did I know it? 12 went into the last 2 digits. And when I added up the digits, I got 30, which is divisible by 3. And if you didn't know if 30 is divisible by 3, add the digits and say, yeah, 3 is divisible by 3. So this is divisible by 3, this is divisible by 3, and therefore this number is divisible by 3. So if you're divisible by 4 and 3, you're divisible by 12. Okay, so let me just erase this a little bit. Got all the rules up here, 2 through 12. Now, suppose you have the following. 75 divided by 102. 2 is not divisible by the top number. And the question is to reduce this. So then you go to 3. You can say, you know what? Those digits add up to 12, which is a multiple of 3. And these digits add up to 3, which is a multiple of 3. That is, 3 goes into both of these numbers. And if you have to do the long division, fine. But you should really know that 3/4 are 25. And you probably shouldn't walk around knowing what 102 divided by 3 is. 3 times 3 is 9. There's 1 left over. 3 into 12 is 34. So now you have this. Okay, well, we know that 2 doesn't work. If you add up the digits here, you get 7. So 3 is not going to work. And for the record, 4 or 6 or 8 won't work. Because if 4 goes into a number, then 2 goes into a number. If you have 28, 4 goes in here 7 times. But 4 is 2 times 2. This has to go in. 2 goes into 28 14 times, and the other 2 goes into 14 7 times. The 2 has to go in. Okay, so we don't try any even digits if 2 doesn't work. So we look at 5. Well, 5 goes into 25, but it doesn't go into 34. What about 7? Well, you should know that 7 times 5 is 35, and that's 1 less. So no, 7 won't go in. 9 won't go in because if 9 goes into a number, 3 must go into it. 11. You know the first few multiples of 11. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. It's not any of those numbers. So we'll conclude that that's reduced. And we 100% used our divisibility rules. If I give you 256 divided by, 28. You can say 2 goes into them. 3, no. Because if you add those digits, you get 10, and 10's not a multiple of 3. But how about larger even numbers like 4? Well, 4 does go into 56. Goes in 14 times. And clearly 4 goes into 28. 4 goes into 28 7 times. And 4 went into 256. It's going to be 64 times. Bring down the 6. It's going to go 64 times. And 7 is prime. So the only way that's going to reduce is if 7 goes into 64. And you should know that 7 times 9 is just below 64. And 7 times 10 is more than 60. Or if you want to, you can use the rule for 7. Take this number and take away 2 4s, which is -2. 7 doesn't go into -2. Okay, so this is done. Knowing the divisibility rules really makes your life easier. I can't stress that enough. Okay, I'm going to make up a problem. I won't even tell you how I'm getting it. Suppose you have 1, 3, 6, 4, and you want to divide this by this number, 2574. 2574. And it comes down to it. Your grade depends upon this. But you know what? I'm going to change that number. 253, 253, 2783. Sorry about that. Okay. 2783. I hope most of the test fails. You'll see why I say that. Well, 2 doesn't work because that's not an even number. So no even number will work. How about 3? Well, if I add these digits, 10 plus 4 is 14. So 3 didn't work. 5's not going to work. Is 7 going to work? I mean, you can do 7 into this number. Goes 3 times, have 6 left over, 8. 7 times 9 is 63 with 5 left over. No, 7 does not go into 53. Okay, so 7 didn't work. If 3 doesn't go into the number, 9 won't. What about 11? Well, even I'm making that mistake. What is 1 take away 3 plus 6 take away 4? If you hate dealing with negative numbers, like 1 minus 3 is negative, don't deal with negative numbers. 6 minus 3 is 4, plus 1 is 5. Let's try that again. 6 minus 3 is 3, plus 1 is 4, minus 4 is 0, and that's divisible by 11. How about the next number? 2 minus 7 plus 8 minus 3. 2 plus 8 is 10. Take away 7 is 3. Take away 3 here. It's a multiple of 11. So now I would divide by 11. How else are you going to know if it's divisible by 11? And all I did was a simple addition subtraction problems. 11 goes in there 1 time with 2 left over. 11 goes into 26 2 times with 4 left over. And 11 goes into 44 4 times with nothing left over. So I divide the top number by 124. Sorry, by 11, and I got 124. And now I know to divide the bottom number by 124 because the alternating sum differences was a multiple of 11. Goes into 27 2 times with 5 left over. Goes into 11 goes into 58 5 times, which is 55. 3 left over, and look at this. Bring down the 3. 11 goes into 33 3 times with nothing left over. So I was able to reduce it. Now, do a lot of scrap work. Let's get rid of it. Now, let's see if this is reducible more. Now, look. If 2 did not go into both of these numbers, 2 will not go into both of these numbers. And since 3 didn't go into both of them, they suddenly won't now. Same with 5 and 7 or 9. Well, 11, who knows? 1, 2, 4. 1 minus 2 plus 4. 4 minus 2 is 2, plus 1 is 3. Nope, 11. And we can stop there. If you know your divisibility rules, you can reduce fractions. You have to know your times table and your divisibility rules. Okay, that completes the video entitled Divisibility Rules. Learn them. They're very helpful, believe it or not.